Sir, granted, sir.
Yeah, checking. So, am I audible?
Yes, sir. Yes, yes.
Yeah. So we are now in the day 3 of this session workshop. And so far we have understood the difference between the cryptography, the various types of cryptography, the need for cryptography, and we also have seen a demo using GNU-PG tool, where this GNU-PG is a software suite that contains a variety of software applications designed for providing security to our package. Now, when we talk about the overall experience, we mainly focused on these areas. Like we wanted to understand the need for security. We also have seen various attacks. Actually, we did not cover the complete set of attacks. And I know if you are really interested, definitely you can take it to the next level by referring or by joining or by self motivating yourself by referring to many YouTube free videos, and so that you can take your experience, hands-on experience to the next level. Whatever we have discussed so far, it's just the theoretical basics. I won't even consider this as an hands-on experience because in reality, security is a vast area and attacks are even vaster than the security providing areas. And coming to the next point, we also have understood, right, the symmetric and the asymmetric crypto system, but we need to understand few more aspects about symmetric and public key crypto system. And today we will be focusing more on the comparison between cryptography and steganography. And we will be also focusing on a demo tool using OpenStego using steganographic techniques. In steganography, we have a lot of techniques wherein I'm going to focus only on the least significant bit steganography, which is also called as LSB steganography. And finally, we will conclude the session by comparing the hashing techniques and the various hashing tools. Okay, so this, if it is a new term, no worries, I will explain the basics. After that, we will have a Q&A session, and whatever questions you have, I'll try to answer so that I can quench the answers or the thirst of your concept. So we understood all these areas, so I'm just skipping all these portions, and we will just directly go to the cryptographic areas and comparing that with steganography. So we understood symmetric, asymmetric, all these areas we are very clear about. Okay. Now, when we compare the symmetric and asymmetric, or symmetric and public key crypto system, or in other words, this is private key crypto system and public key crypto system. Here we have only same algorithm, right? If you use plus, use minus for the, say for example, if you're using plus for encryption, do minus for decryption, right? The reverse. Whereas here it's totally different. Public key encryption, for encryption, you will have to use a different algorithm. For decryption, you will have to use a different algorithm. But in conventional cryptography or in conventional encryption models, the quite opposite for the encryption will be the decryption, right? Say if you shift 3 letters, then shift back 3 letters for decryption. Whereas here it's going to be different because the keys are different. For encryption, we use public key, and for decryption, we use private key. So here it uses same key, here it uses different keys, and obviously the keys are kept secret here, right? But here only one of the keys is kept secret. What's the key? The private key is kept secret, whereas the public key can be displayed publicly also, even in a public key directory or on a website, or send email, or post it in a public key infrastructure, or even you post wherever you want, even in Facebook, Google, wherever you want, you can post it. And but the main thing is conventional schemes are faster because encryption and decryption, there are no different algorithms, just the reverse, right? But it's comparatively slower than the conventional encryption because the security offered and the idea behind this is entirely different. And coming to the last point, we have all the classical encryption techniques, whatever we have seen, like Caesar cipher, the mono alphabetic cipher, Playfair, Hill cipher, all these are classical crypto systems which come under the conventional. Nowadays, we are not using this conventional. Please don't get confused. I'm not telling we are not using symmetric. We are still using symmetric. Symmetric is still having its own advantages. My intention is under conventional, under symmetric, under conventional. Okay, so this is what I am focusing on. And coming to public key crypto system, we have a lot of crypto systems like the RSA crypto system, the Rivest Shamir Edelman crypto system, Diffie-Hellman crypto system, elliptic curve cryptography, Rabin crypto systems, and many more algorithms are there. So this is what the general comparison, and we also have seen a demo. Now we will come to steganography. First, we need to understand, say, I want to send a confidential message. For example, the message is hello world. The problem is I should not send hello world as such as a plain text, because anybody can sniff or anybody can indulge in some attacks. It may be an active attack or it may be a passive attack. And that's why we are going towards, encrypting the data before we are sending it. Okay. So give me a minute. I will just adjust my microphone. Thank you, guys. Coming to the topic, I'll just share my screen. Okay, in cryptography, what we used to do normally is when we have a plain text, we will be converting that plain text into some unreadable text, right? Say if your plain text is hello world, we will be converting that into some scrambled text, right? Anyway, the scrambled text indicate that that message is encrypted, right? So do we have any alternate technique for providing security without encryption? Of course, encryption is good. I won't say encryption is not good. It's good. But we have some alternative techniques like steganography. What we are going to do in steganography, we are not going to generate ciphertext at all. We are not going to convert the plain text into ciphertext. Rather, we are going to hide, we are going to conceal the existence of the message. So we are going to hide the existence of the message in a different format, right? I'll tell you. So the simple idea behind steganography is hiding the message. Say when we are going to send a message, and when people sees that message, they won't even understand that there is a hidden text inside it. Okay, so that is what we call as steganography. Now we need to understand clearly that cryptography is dealing with encryption and decryption, whereas steganography, it is not an encryption scheme at all. It means we are not going to convert the plain text into ciphertext. The output is not going to be the ciphertext here at all. Rather, the message going to be the same message only. But what is the difference is there are some hidden information that we are going to attach with the message. So we understood cryptography renders the message unintelligible to outsiders. Obviously, right? When outsiders sees, they will see the message, but it will be unintelligible, right? Because what we are doing, we are doing some various transformations or various algorithms we are enforcing in order to make that ciphertext. And in steganography, what we are going to do is we are going to hide. Can you see there is a message hidden on this example? Simply encrypt correct reading exactly twice. Actually, when you look at this message, you will see that there is something written, right? Simply encrypt correct reading exactly twice. But what is the logic behind this is there is a secret message which is hidden here. The first letter of every word is the secret message. The message is secret. When people sees this, they will not be able to exactly identify, right? So this is not the exact steganography that we are talking about, but this is just an example. So what we are going to do here is understanding what are all the various things. See, once upon a time when we have a group of characters, then we will mark special characters in order to denote the hidden message. So character marking. You can also use invisible ink, because this invisible ink will not be revealed on the naked eyes or in the normal light, but when it is exposed to sunlight or brighter light, it will be visible. We had pin punctures. I request you to make a note of this and just go through it whenever you get free time. Okay. Then typewriter color ribbon. All these are classical examples of steganography. Now, how we can incorporate this in real world, in computer science, in digital platform? So that is what we are going to see shortly. But the drawback with steganography is it involves a lot of overhead when compared to cryptography, because you just give a plain text to the encryption algorithm. That's it. Your job is over. Give the key, what key is required to do the encryption. Give the plain text and the key. Your encryption algorithm will convert that plain text into ciphertext, then send it across the world. No problem. But here we have to involve a lot of additional things. And also, once the system is discovered, say you are hiding, you are hiding some message on the image, for example. Then once if somebody discovers that message, obviously it virtually becomes obviously worthless, right? Not only just with steganography, even with cryptography, if key is identified, or if key is revealed, or if key is compromised, everything is gone. Okay, so please note, if you want more security, you can combine, you take a message, encrypt the message first, generate the ciphertext, and after generating the ciphertext, then hide the message using steganography, right? So this is what actually one of the ways to improve your security. You need not do much. Already a lot of researchers have given different ideas, different methodologies. Take multiple ideas, put together, and just develop a single suite. That's it. And the example that we are going to focus today is the least significant bit cryptography, sorry, steganography, the least significant bit steganography. So understand, steganography means it's not encryption and decryption, hiding the message, hiding in some other format. Okay. So LSB, you guys know, it's least significant bit. When we have a set of bits, okay, so in computer science, we are very much aware about 8 bits, right? Most of the things are represented in 8 bits. When we talk about these 8 bits, the last portion from your, if you proceed towards your right hand side, these are least significant bits. The value is going to be very less, right? Say, for example, this is 2 power 0. 2 power 0 is 1. This is 2 power 1 is 2. This is 2 power 2 is 4. You see, the value is keep on increasing when we move towards right, when we move towards left, right? So whatever is there on the right hand side is going to be the least significant bits. For example, you just take the last 2 bits. Okay, the last 2 bits. These 2 bits can be least significant bits. You can also take 3 bits as the least significant bits, or you can also consider only 1 bit. Okay, whatsoever your methodology only. But I am here considering 2 bits, the least significant 2 bits. And these least significant 2 bits that I have taken here, right? I am going to remove that. See, every message will be splitted into 8 bits, right? Then focus on the last 2 bits. Okay, last 2 bits. Remove those 2 bits. I mean to say, retain 101010. Then remove these 2 bits, or make the bits blank. And if you have your confidential information, convert that into binaries and take the first 2 bits of your confidential message and place it here. Okay. Say, for example, if the first 2 bits of your message is 10, place 10 here. If it is 11, place 11 here. Now you may be asking me a question, will that make any difference? That's what we are going to see now. Say, this least significant bit steganography actually is well defined in the RGB color model. I know it will be difficult, but let me explain you. I'll try to keep it simple. Any pixel that you see, say if I click here, right, all these, the whatever the image that you are seeing on the screen, everything is of pixels only, right? Pixel, pixel, pixel. The pixel, the expansion for pixel is picture element, right? See, these are the elements that are constituting in order to display a picture, right? In simple term, it's pixel, pixel. Now when you take one pixel, every pixel will be of colors, having some colors, and the group of these pixels which are given with certain colors, that is actually constituting an image. Now when we follow RGB color format, using this RGB we can derive all other colors. Okay, let me explain you why. Suppose if you are using this RGB as a color model function, okay, R stands for red, G stands for green, B stands for blue. When we use red, green and blue color model, then using these 3 parameters, we can get almost all colors, all possible colors. Let me show you a demo also shortly, but for now, just understand. Suppose if this parameter, or if this function, if we want red color, just have this color to be highlighted. For example, RGB, 3 parameters are there, right? The red parameter, the green parameter, and the blue parameter. Now, every parameter will be of 8 bits. All ones in these 8 bits, the maximum value will be 255. All zeros in these 2 bits will be 0 only in decimal. I'm talking about binary. So when you set all ones here, 1, 1, 1, 1, 1, 1, 1, and 1, 8 ones, 8 bits of 1. Okay. In that case, the maximum value in decimal will be 255. So what you are doing when you call the function RGB by passing the parameter 255 for the first parameter and setting 0 and 0. What does it mean? In binaries, all are 1. It means the color that this pixel is going to get is a red color. And obviously, if you want green color, disable the first and the third parameter because the first is red and the third one is blue. Then make the second parameter the maximum 255. Obviously, for blue, the last parameter will be set high 255. So what we are understanding here is instead of using the entire bit of pixels, right, all 8 bits, we are going to take these least significant bits and we are going to store our data inside this. Let me show you that. Can you see any noticeable difference between these two elements or these two pictures that I have projected? See, when you see, you will say both are green color only and you don't even know there is some modification here. See, if you want to get this green color as the output for every pixel, it's the same color, right? So in that case, what RGB value you will be setting? The red value will be set as 0. The green value will be set as maximum 255 and the blue value will be 0, right? Because our intention is to set green color. Fine. Now, here also it's the same green color, but what is the difference between this and this is that I am not using the last 2 bits. That is these two least significant bits. I am making it as 0. So obviously in decimal, it is 252. Fine. And this is 255. Now, what difference does it make? It doesn't make much difference. And that too, when you are given with these two pictures, you will be able to see some difference. Imagine I am giving only this picture. Obviously, you will not be able to see some significant difference. So what I will do, I will just show you one real-time example. I will just open my Word document. So what I will do, I will just create some image or something like this. Insert picture. I will picture or what? I will give some shape, for example. Okay. I will use this. So I want to give some color to this thing, right? So I'll just open this, or I'll do one thing. I will reduce this. I will make a copy. Okay. Now this is in blue color. So I'm right clicking on it. I'm filling it with more colors. And I'm choosing what color model? RGB color model. Can you see here? The color model I'm choosing here is RGB color model. So give this in decimal. Suppose if I want to be in the same green color, so I'll be setting the red is 0, green with 255, and the blue will be with 0, right? So I'm getting this color here. Okay. So if you note here, just focus on the inner color. Don't focus on the outer color. I'm just filling this. So what is the value? I'm going to the format picture, fill. What's the value that we have given? 0, 255 and 0. And here, right clicking on it, filling the color, more color, and for I'm using the same RGB model 0 instead of 255, and like in the previous case here I'm going to use 252 only, and just see what difference does it make. So the last 2 bits you are not using. Why don't you use that for storing your information? Because even if you store your data maybe 0 1 or 1 0 or 1 1, that is definitely not going to make much difference. Say I'm just going to the same one, more colors. Instead of 252, if I make it as 254, what difference does that make? Not a noticeable difference, right? So the idea behind this is we are going to make use of those 2 bits, right? So that's the hero here. So that's how it's going to function here. So these 2 bits, the least significant bits, are going to be used for storing our data. So these least significant bits can be used for storing the information, our confidential information. Say here is one image where this image is without hidden information and this image is with hidden information. Now you are not making any noticeable difference, right? And now you might be asking, where is the data that is actually stored, right? It's all in the least significant bits. Okay, I'll give you a demo now, then it will be easy for you to understand. Okay, so let's now focus on the demo part. So for that, what I'm going to do is I'm going to make use of this ready-made tool, the OpenStego tool. You can also download this. It's an open source tool. So for OpenStego tool, I am going to use the same image because after creating this image only, I've just taken a snapshot of this. So I'm having Blue Orchids file, which is going to be the original image. And I'm going to store hidden information in this original image. And what I'm going to do is I'm going to generate the output in this output folder. Okay, no worries if things are not clear. So what I'm doing is I'm just OpenStego tool. Just download this from the internet. So what I'm going to do is I'm not going to deal with digital watermarking. Okay, I'm not doing this. I'm doing data hiding. What is data hiding here? Steganography, right? So what is the message file? It's saying what is the confidential message you are going to do, right? So what I am doing here is I'm going to the input folder. Let's say the message that I'm going to send is a notepad file, right here. Let's say this is my message. Let me name it as my message. And what message I'm going to do is somebody is ordering someone, okay? Make arrangements for plan B. Execute plan at Panimalar. Okay. For more inputs, contact. Who is the guy? I don't know. Praveen, for example. Okay. Contact Praveen. Let's say this is the confidential message we want to send, but instead of converting this message into on this image, this is the source image. Fine. So on this image, we are going to hide. Let's see that now. So we have an cover file or we have an outer file and we have our confidential message here. So I'm going to the OpenStego tool. I'm going to the message area. I'm just going to the desktop, this folder. I have created a folder, right? So what input I'm going to give? The message, right? The message is actually in the input. So I'm just choosing the message here and the message is now chosen. And it's asking us to give the cover file, the outer file from where we are going to hide this, right? The cover. So just open this and click this blue archids file. This is the cover file and where you are going to store the output, right? So I'm just clicking here. Let me just paste it in my output folder. Okay, in the OpenStego we have output folder, right? Just please be noted that the output folder, I'm just giving what file name, what image I'm going to convert. Can you see here? I'm converting it as a PNG file, an image file. Let us say hidden file, hidden data. Okay, the file name that I am giving as hidden data. Okay, before that, let's confirm that this output folder does not contain any file like hidden data, right? There is no file called hidden data here. So I'm going to the logic and I'm clicking on this. Can you see here? The output is going to be hidden data, where in this output folder, the hidden data PNG file is going to be sent. So for more security, it's asking you to enter a password, right? Optional only, but I am not going to make use of this. I'm just hiding the data. Yeah, one file is generated. If you go to the output folder that we have created, can you see here? Now it is having a file called hidden data, the Stego file. This is actually the Stego file. Stego means the outer image contains hidden text. If you open this image, again, you will never see the noticeable difference. Now, where is your hidden text stored? In every pixel will be having RGB color parameters and every least significant bit, right? The red parameter, the green parameter, the blue parameter, in all the least significant bits, your data is stored. What is your data that we have stored? Your data is actually this my message, right? Make M is of 8 characters, right? What is the ASCII character for M? 8 bits. From those 8 bits, the first 2 bits are stored in the first pixel's first least significant bit. Likewise, every particular pixel's values will be stored with the binary equivalent of these message. Okay. Now let's see. Let's say the receiver has received it, and receiver has received. You have sent this Stego file to someone. Where is your Stego file? Here is in the output folder. You have the Stego file, right? Say you are sending this Stego file to maybe some guy. Okay, XYZ. And this XYZ guy, after receiving it, he wants to open it, right? So he does the reverse operation of this. Very simple. Instead of hiding the text, he's going to use the extract to text and then he's going to input the stego file. What is a stego file? That contains both the cover file and the confidential information. My stego file is in the output folder, and can you see here my output folder contains only one file, the stego file only, right? Now I will extract the file, the confidential information, and I will place it in the output folder itself. Okay, so I will just copy this location for easy accessibility. So what I am doing now is I repeat, I'm just going to extract data. I'm inputting the stego file, which is in the output folder, the hidden text or hidden data, and where my output is going to be stored. Just watch this folder. And I'm just clicking on the location. I'm going to the output folder. I'm opening it just to see if you had set any password, just give the same password here. I'm extracting the data. Now just see my actual message.txt is now regenerated in the output folder. And let's open it and see, yes, the same file, the same data, right? Actually, this data is now in my message, which you extracted, but our actual data was in input folder. Just we have hidden the text, but you need to understand how it actually works, how this algorithm actually works. Every image, so if you want to, if this is actually a small software code only, okay, it's not a big deal. You can also easily try this. See, even in Python you can try this. So this is actually a Java application where outer text box is given. So what is the logic behind this? If you are good in Java or C++ or Python, just to create a window like this, create all necessary text boxes, covers, and command boxes, everything, and then input the file. Let the file be read. All the files should be, every pixel should be read. Then remove all the least significant bit using some for loop or any condition. Then do this job. It's simple only. It's not a big deal. So you can also try this as a mini project and learn more about this. So what we have seen now is a demo using OpenStego. So I'm not touching upon the digital watermarking now. Okay, so let's see that later. And before that, we will focus on certain cryptographic hash functions, and then we will have a Q&A session. Okay. Now, I will ask you some question. It's a Q&A session now. Let me see how much knowledge you have gained. Okay, so randomly, if you are confident, you can answer this question. Okay, so it's just a Q&A session. No worries if you are providing wrong answers. I'm not going to harass you or penalize you or punish you in any way, right? It's just an interaction. So I want people to participate in this. Okay, yeah. Question number one, let's have a Q&A session for 5 minutes. Let's see how much knowledge you have gained. Then it will be easy for us to understand the cryptographic tools. Okay. Okay. I would say cryptography is equal to encryption plus decryption. Is it true or false? Can someone answer? I'm telling, no worries, nothing wrong in giving wrong answer. Just give a try. Don't take more time because we have some more things to deal with.
True. True, sir.
Okay,
True,
thank
sir.
you. Thank you. Thank
True,
you so
sir.
much. Now, what I want here now is the next level. In cryptography, keys must be kept secret. True or false? In cryptography,
No, sir. No, sir.
key must be kept secret.
No, sir.
Why? No. Key is the important information you
The
should
key.
not reveal, right? Key must be kept secret, correct? Will
Public
you
key.
share your key? Key is secret, right? Okay. In cryptography, the plain text should be kept secret. True or false?
True, sir.
True, sir.
Yes, because if you want to send plain text and if you're not bothered about any confidentiality requirement, you can send the plain text just like that, right? But why we want to convert that into ciphertext? Because we don't want our plain text to be revealed to someone, right? That's why. Then now answer this, think about this and answer. You confirmed in cryptography, plain text should be kept secret. Yes, true. Keys should be kept secret. Yes, true. In cryptography, encryption algorithm should be kept secret. True or false?
False, sir.
False, sir.
People are telling false. Can you justify why it is false? Even if you keep that encryption algorithm secret, it adds more value, right? It gives more security, more power to your concept, right? Okay, false is the right answer. I agree. You need not, make your encryption algorithm secret. I'll tell you. Just see the screen. What encryption algorithm we are using here? It's RSA algorithm, right? The public key algorithm is RSA algorithm. Yesterday we just saw. This is RSA algorithm. It's not kept secret. But you know why it's not kept secret? Because encryption algorithm, anyone may know it, no problem. But the real security is with the key only, right? As long as the key is secured, they will not be able to break it. Now, okay, now this is fine. Okay, now it's quite tricky question. Let me see if you can answer this. In when you convert your plain text into ciphertext, right? The concept or the context that you are achieving is confidentiality. True or false? Confidentiality. I think bit tricky. Anyway, yes, confidentiality only we are achieving because no one is going to see what the message is, right? So confidentiality, we are achieving it. Now, then in security, we have a lot of requirements. We want a lot of things from the from the algorithms. It should provide confidentiality. Yes, it should provide, right? No one should see your confidential information. It should provide authentication also. What is authentication? Say, if you are going uh, let's say you are going to access your ATM machine and get some money from the ATM machine. In that case, what authentication mechanism they have followed? Passwords, pin numbers, right? So on, unless you give the right pin, you will not be able to get. So pin number, giving pin is a password, is an authentication mechanism, because we need to ensure whether right person is accessing. If you log in with Gmail or Facebook or LinkedIn or Instagram, if it is asking you for the password, so that password is an authentication mechanism, right? So confidentiality is hiding the information or converting the plain text into ciphertext so that nobody sees your message. Okay, yeah, Ramya, you have some doubt, it seems. Is it by mistake you raise the hand, or
Any doubts you can ask. No, no issues.
no
Don't hesitate
problem?
to
Nothing
ask.
harm in asking. It's good if you interact.
Senthil sir, sorry, Prabhu sir, I just wanted to ask a question. I texted
Yeah,
you a question yesterday. It's from a student. I
yeah.
just wanted you to clarify it, sir.
That's what I'm going to come now shortly. Yeah, I remember the voice message, right?
Yes, sir, yes.
Yeah, I remember that. Okay, I'll take it as Ramya's hand gesture as a inadvertent by mistake one. Okay. So what I was discussing is a lot of requirements. Say in if you have your phone, if you don't want your phone to be accessed by anyone, you cannot every time go and store every message into ciphertext and store it secretly, right? So at the same time, you want someone not to actually use your device. In that case, we have a lot of a lot of authentication mechanisms, AUTHETICATIO, and authentication mechanisms like fingerprint, passwords, pin numbers, and then we have some patterns, right? Pattern, you draw the pattern only, then it will open. You have facial recognition, you have voice recognition, every authentication mechanisms we have. So this is also required. We also expect our secure system to provide us authentication also. At the same time, the very important requirement, one more important requirement we are expecting from secure system is integrity. INTEGRITY, integrity. See, have you ever witnessed, you are sending a document or you are sending a text in WhatsApp to your friend, or you are sending an email document in Gmail, or you are posting something on Facebook? Have you ever felt that I posted this, but for somehow a different thing was posted? Have you ever said, even if you do a mistake, that mistake only will be reflected, right? Have you ever witnessed a single scenario where you can claim innocence by saying, hey, I did not do that. I actually did this only, but somehow it has been changed? I would say never, never ever, because our secure system is not only providing confidentiality, it's not only providing authentication, it is also providing integrity. Whatever you are sending, the same only the receiver will be receiving. They, even if there are some modifications, it can be easily found out. Okay, so that's the logic. Because I'll give you one authentication mechanism here. Suppose if you are going to send a confidential message, hello, okay, and with this you are attaching this to. Okay, now if the message is modified, this too indicates that let's say this 5, not 2, I'll say it as 5. Let's say this 5 indicates that the number of letters in the message. You are appending some additional information or redundant information with the message, so that when the receiver receives it, let's say the receiver receives this information and he counts what all the data, how many characters you have sent, it's matching. Let's say during the transmission, if the attacker is modifying it as like this, obviously this information will not be matching with this. So this is integrity violation, right? So whatever you are sending, the same only receiver will receive. Now, how to enforce that the data is not modified during transmission? See, if you want confidentiality, good, you can go for encryption techniques or steganographic techniques. That 100% it provides confidentiality, right? Your data will not be revealed. If you want authentication, you can go for digital signature techniques. Okay, in live in computers we have digital signatures. If you sign, it proves that you are, suppose if you are getting a circular from your principal, how you are confirming that the circular is from your principal? Only because there will be signature on it, right? So that signature on paper is acting as an authentication to prove the identity of the sender, right? Likewise, in computers we have digital signatures also. Not digital signature means not just signing on the image. Suppose if you open a paint, if you open MS Paint and say if this is your signature, maybe it might be a scribbling, but say this is my signature, okay? And do you say this is a digital signature? No, this is not a digital signature. This is an image. This is not digital signature. Digital signature means with the message, you are going to attach a piece of code, okay? A software piece of code, say for example, like this. And this code will help you to determine whether this message is modified during transmission or not. That is what we call as digital signature, okay? So now what we are actually focusing on is the integrity schemes, okay? So we are focusing on the cryptographic hash functions, where these hash functions are helping us to achieve integrity. In simple terms, whatever the sender is sending, the same only receiver is going to receive, okay? So that we need to ensure. So that we call as integrity, that we technically call as integrity, but hash functions are helping us to do that. For example, a lot of MD5 techniques are there. Can use a message digest. I told you, right, the signature. Say for example here, I'll open this. I'll delete everything. Let's say I'm going to send a confidential message, kill coronavirus, for example. Okay, let's say this is a confidential message. And with this message, I'm going to attach, for this message, I'm generating a software value. Okay, let's say this software value is this. Okay, now I'm going to send the software value to the receiver. When the receiver will be receiving entire set. Okay. And what the receiver will be doing is he will be taking this particular information and he will be giving it to the same hash function like the sender. Sender, how he is generating this? He is going to generate this by giving this plain text to a hash function. Hash function will give a signature. I am referring this as a signature, for example. Okay, signature. So I am referring this information as a signature. Multiple terms you can use. This is signature or digital signature. Okay, I will specify it as digital signature, or I will refer it as a hash value, or I will refer this as a message digest. According to the algorithm, the name varies, nothing more, nothing specific, or it is just a tag. And what value we will say, hash, digital signature, fingerprint. Okay, fingerprint. These are the various words that we use. Okay, fingerprint. All these words are referring the one and the same. Okay, only multiple words are used. Say what we are doing with the message, we are attaching the digital signature or the hash value or the message digest or the tag or the fingerprint. Okay, so what this fingerprint is going to do is it's going to help us to determine whether the message was modified during transmission or not. So when the sender is able to generate this, the receiver will also be collecting the message separately and giving that message to the hash function and generate the fingerprint or hash value. And then this will be compared with what was sent by the sender. Receiver receives this, he will again generate this hash value from his side, and he will compare that value with the attached value. If both are matching, then he can confirm that yes, the message was not modified during transmission. And that's how it's happening. And that's why in today's world, whatever you post, that only is being displayed, that only is being posted, not even one additional dot, because that will make a huge difference, right? Now you may be asking a question, what if this is getting modified during transmission? Again, any transmission, during any transmission, if anything is modified, that is illegal, right? Again, this will not match for sure, because for this, if you say this is generated, for this plain text, if this is generated, and if the digital signature or fingerprint is modified, and for this, definitely during comparison, this will not be matching, right? Because the receiver, once after receiving this information, he will generate this. And what was sent by the sender? A different value. It's a modified value. Again, this will not be matching. So any modification can be easily identified. So from this, what we are achieving is the message integrity, right? So message integrity. And we have seen some techniques, right? We for cryptography, for confidentiality. What are the techniques we have seen? Cryptography and steganography. And for message integrity, we are going to see hash functions. Okay, these hash functions, there are a lot of hash functions, hell lot of hash functions. I'll give you some examples like SHA, secured hash algorithm, MD, message digest, MD4, MD5, all these are versions. Okay, MD4, MD5, SHA1, SHA 512, SHA 256, all these are versions. Okay, I'm not going into the details. 512, SHA 1024, 1024. I can even show this to you. Yeah, I'll just show what hashing algorithm this is using to ensure that, see, whatever I speak, that only you are receiving, right? So see, let's see that. What hashing algorithm they are using. Just scroll here, scroll, and you will somewhere see the signature algorithm. Signature, I told you the word, right? Some words, signature algorithm. What signature algorithm they have used? It's SHA 384. I told you, right? SHA 384. So 384, the version is here. SHA 384. Okay, whatever version, it's all depending on the key size. That's it. Okay. So likewise, we have a lot of tools on the internet to ensure integrity. Okay. So I'll give you one example. See here. MD5. Okay. You take this website as an example and try downloading this. You have online hash generating tools also. You have, for example, I'm just going to the same website which we have seen yesterday, right? Say from this website, I'm going to download this application, right? GPG for Windows. I told you the same site yesterday, right? Before downloading, you have to ensure first thing is whether you are downloading this from the authentic site, the first thing. And after downloading, you need to confirm whether whatever the sender has sent, that only you have received, right? There, because there are some modifications. You might be downloading it from an unauthentic site where these guys would have injected some hacking code inside the exe file, so that once you installed, your computer will be reporting your data to someone else when it is connected over internet, right? So you should confirm that. So what you need to do is, after downloading this file, it's of 31 megabytes, right? So let's say this is of some characters. And after downloading that, you just generate a SHA fingerprint like this. I know things will be difficult now. What I will do, I will just give you one example. I will go to, I've downloaded this MD5 tool, right? So this MD5 tool. So what I'm going to do now is, I'm sorry. I'll go to the command prompt. I'm just going into this location. Can you see I am in this location? Okay, I'm just, let's open this file, nature. This is an image, right? Let's see what is the signature that we are getting for this nature file. MD5 sums space, what input I am giving? Nature.jpg. So I am generating the signature for this input, nature.jpg. You see what is the value that we are getting, the fingerprint value? This is the fingerprint, correct? You are able to see SHA fingerprint or signature or message digest or any word you can use. I will refer this as signature for now. Okay, let's the signature be this one. Now what is happening? If the receiver is receiving the same nature file, and if he run the same commands using the same tool, he will be able to get the same value only. How many times you run, it doesn't matter. You will get the same value only. Can you see here? You will get the same value only. There will not be any modification. Now what I'm going to do is, I'm going to just edit this. Just see guys, I'm just going to edit this. I'm editing this in Notepad. I'm just scrolling to the deep. I'm just putting one small dot here somewhere. Okay, somewhere here. Okay, just I have added a dot here. And then just I'm saving it. Okay, I'm closing it. Now if you open, you will never see the difference. Just see where the dot is. 1 pixel I have modified. Only maybe 8 bits are modified, right? Maximum. Or who knows, only 1 bit is modified. I don't even know that. Now you see, for the same modified image, if I generate the hash value, you will see a completely different value. Can you see here? It's not matching. Sender has sent the message with this digital signature, while receiver receiving it, he is getting a different digital signature. What does it mean? Fingerprint is getting. What does it mean? Digital signature is entirely different. Don't get confused, but still you can refer it as signature. Okay. So it means that the message was modified. Likewise, when you are downloading something from the internet, always ensure you are doing it from the right side. Okay. And always see what fingerprint value that they have used. Sender is saying that, let's say this GPG for Windows is the sender, right? He is actually the sender now. The sender is telling, this is the file, download it from here, and this is the fingerprint or checksum. I forgot to give this value. Checksum, you can add one more equivalent word, checksum. All these are referring here one and the same. Okay. So he is generating this. So after you download this, what you need to do is very simple. SHA-256 algorithm you open. Okay. You can open any online tool. I'll just open this online tool. I'll just open this tool, guys. I'm opening this tool. Go to this tool, choose what algorithm you want to do. Okay. So what, and you see how many algorithms are there. All these are hashing algorithms, MD5, MD2, MD4, MD5, SHA-1, SHA, various SHA versions, RIPE MD, Whirlpool, Tiger. Even you just scroll, how many, Jesse, right? All these are signature generation. Now you just input, say for example, I am giving hello, right? Or Pani Malar Engineering College. I'm using, say for example, SHA-256. What algorithm they have used? SHA-256, right? So I will use SHA-256. I'm hashing this. So let's see what value we are getting. We are getting this value, right? Just make a note of this. I'm just making only one small space additionally. Okay, it starts with 8. Just see, guys, 8BD. Okay, for example, 8BD. Okay, 8BD. I'm just modifying this text, adding a small space, hashing this. You see, it will be completely different. Initially it was 8BD, but just see what actually I did. Only one small space added. So what I mean to say here is the signature, the hash value will never match if the message is modified, right? Because it will be giving a unique message. So that is what I am telling you. Always, whenever you download anything from the internet, just see what hash value. Any authentic software you download from the internet, they will be giving this value. Okay. It doesn't mean that they should always go with SHA-256 only. They might choose MD5. They might choose any algorithm, right? RIPE MD, Tiger, anything, whatever. I also opened this link where to download. Where is that? That MD5 that I have shown as a demo. Yeah, from this MD5 sums, right? So from this, you can download the zip file. This zip file, here it is. It's just a small tool. And after downloading it, you can even compare. Here also, they have given the value. After downloading that, check whether you are getting the same value, right? This is the hash value that you are getting. Okay. Ensure what algorithm they have used. It's MD5. Okay. So for MD5, you will have to confirm it. See, when you are given this, it will be difficult to find what message it is, that what message is, what is the actual message. It's really difficult. It's one way. Okay. You can generate the value. When value is given, you can generate this plain text or the file or the input. Okay. It's not possible 100%. And these are all the basics behind the cryptography. So what in this presentation, what I touched upon is integrity areas and cryptographic area, right? So in the overall 3 days, what we have seen, in the overall 3 days of our experience in this workshop, we have understood quite a lot of interesting things like the need for having computer network security, the attacks, and we have also seen some email spoofing and phishing attacks. Today we saw that the differences between the conventional and the public key crypto system. And we also have seen the difference between cryptography and steganography. And we also have dealt some hashing techniques, not in detail, but still we have referred what is hashing, right? So here, encryption, it deals with confidentiality, right? It provides confidentiality. Digital signatures provides authentication because we know who is sending the message. We need to understand, right? And then Hashing provides integrity, right? Integrity. So we have touched upon these three aspects of cryptography, or network security to be precise: the confidentiality requirement, the authentication requirement, and the integrity requirement, right? Also remember, authorization, lot of techniques are there, but still, as a beginner, with this knowledge, you can certainly start your journey. I would say the reason why I'm telling you is, if you are not interested in programming, don't force yourself. Okay, I have to learn programming. Learning programming is always an added value, right? It's like learning additional language. See, if you are I'm sorry to say this, but still I'm recording this. Say if you are a language fanatic, hey, Tamil enoda uyir, I will use only Tamil. That's good. If Tamil is your mother tongue, accept Tamil. Good. Yeah, Tamil is my mother tongue, Tamil is your mother tongue. Okay, let it be. But it doesn't mean that learning other language is disrespecting your own mother tongue, right? Always learn other languages also. See, have exposure on variety of things. So what I am projecting here is, likewise, if you are not interested in programming, no problem, nobody can force you to learn programming. But knowing programming is an added advantage. But if you want to be a simple engineer or a value added engineer, that you have to decide. If you want an engineer, okay, that's good, because nowadays we can see in every home there will be an engineer, right? Like a fridge, like a washing machine, like a television, like we have engineers at our home everywhere, right? So not merely just an engineer, you want to be a value added engineer, where industry should be requiring you people only. See, think about yourself. If you go to an interview, or you just visualize yourself in front of an interview panel, you know nothing, and you still want a job of 5 lakh per annum or 10 lakh per annum. Who will give? If you are the owner, will you give a job to them? Definitely no. At the same time, this industry, this current corporate world is not expecting, shooting the star from here with a C program. That's not they are expecting. But if you know that much skill set, you will be respected. Your growth will be truly awesome. At least we should be more focused towards our basics, right? Say you know only Python. While preparing a resume, just mention you know Python, that's it. It doesn't make sense when you say, oh, my resume should be filled up with, like, I know C, comma C++, comma Java, comma Tamil, comma English, comma Python, comma J plus J plus plus E plus E plus plus. No, don't do that. Whatever you know, you just see your resume. It should speak for you. That's it, in simple term. If people are not getting an opportunity to know about you, your resume or your curriculum vitae should speak about you. Okay, so don't put unnecessary things, whatever you don't know, on the resume. If you know only Python, no wrong in it, in mentioning that you know only Python. Languages known Python, that's it. But after mentioning that, if certain basic questions are put on to you, and if you are unable to answer, then what's the use of mentioning that? Then it is equivalent to you are not knowing Python, and still you are mentioning that you know Python on your resume or in your curriculum vitae. So what I suggest is, have a sound knowledge. Have a sound knowledge, because this basics, if you are very strong, you will be able to acquire any kind of higher level, concepts. I would say engineering itself will be really good, because computer science and engineering will cover almost all the areas. See, in software market, programming is not the only option, like I told you, right? If you are good in programming, you can go as a developer. Other jobs are definitely there, right? If for that, you might not need a programming, but still nowadays industries, few development industries are expecting full stack developers. I will explain that now. Say if you don't know programming, do I have any career option in IT industry? Yes, of course you do have. You can go as a database administrator. You will study database management system, DBMS, right? So you can go as a database administrator. You can go as a system architect. You can go as a developer. You can go as a network administrator. If you study computer networks, you can go as a network administrator. If you study cryptography and network security, you can go as a security professional, right? And if you know only designing, I am very good at logic making and all, then go as a designer, right? No sir, I don't know, but I am very good at fault finding. If somebody does some work, I am very good in finding faults. Go as a software tester. Ask someone, let them. But for software testing also, you should know programming, I am telling you. Okay, So that's what I'm telling you. It doesn't mean that programming is the only area that computer science is revolving around. It's not like that. Knowing programming will be an added advantage. So learn the programming, be strong in the basics. Industries are not requiring big things from you, but they will make you to do big things when you are very strong. You just think, have we ever imagined that we are sitting together, we have not even met, right? In this room, in this virtual room, we are 100 people are interacting. I am delivering here from one part of the world, right? I am in Bangalore, I am delivering my lecture here. People around Tamil Nadu or Chennai, whatsoever, or Tiruvallur district, they are listening to me. Just see, 50 years ago, if somebody had told this, there will be, the future is like this, one box will be there, you sit in front of the box and people will be doing that box, we would have ridiculed at that guy, because we hadn't even thought that digital environment, this digital world will be making a revolution like this, right? See, nowadays, you see, have you ever seen a person without a mobile phone nowadays? Just see that the world is on his hand, right? So that's how the digital environment made a big impact in our day-to-day lives. So you be a contributor to the community. What I mean is the technical community. Okay, I'm not talking anything with respect to the community that you are referring to. I'm talking about the community, the technical community, the computer science community, the engineering community, right? So do something for the community. Don't be merely a simple engineer, be a value added engineer. I know, like Pradeep Ranganathan said, right? First step only is really difficult. Take the first step, okay? Because we hadn't even referred a book for walking. We hadn't even referred a book for speaking. When you were a kid, you saw what people were doing. We attempted that, right? Did anyone teach you that, hey, this is how you should walk? Take your first step, place it like this, then you will start walking. Did you refer a notes for doing that? No, it's all when you not even cognizable, we were able to do everything. But once we have gained this cognizable level, once we know what is good and what is bad, we should not fear for anything. We should directly step into, you just dive into the water, learn swimming. That's it. Okay, unless you dive into the water and start learning swimming, nobody can help you. At least you should take the first step. So now I'll keep the session open for some Q&A session. If you have any doubts, you can ask. I'll start answering the first question. I think the question would have been already clarified. Some person has asked that voice messaging, it's all binary data only is going to be done, right? If I say text, even text is going to be encrypted, but not as a text. Computer knows only binary, right? First, it will convert everything into zeros and ones, and the encryption or decryption algorithm works on binary only. Even the ciphertext, what we are saying, that is also in binary only. Okay, so any data, voice data or video data or text data, everything is of binaries according to a computer. A computer doesn't understand what it is, right? It knows only zeros and ones. I hope I have answered that question. But at the overview level only, I told you that this is what is the plain text and this is how it is converted. But actually, they are binary level only. Okay, I'll keep the session open for 5 minutes. You may please interact with me, and I really thank you very much for your patient listening. Hello, are you there?
Students, if you have any questions, you can ask. And as I told you, it is the final
Not mandatory. If you want to, if you have any doubts, you may ask. Yes.
The final opportunity for you, because we have the resource person directly from the company, one of the renowned company, networking company, it is Cisco. So
Cisco
number
is
one
the
in
leaders in
networking.
the networking, man. Try to get a
What,
job in Cisco. It's really a dream job for many. Okay.
sir, let
If
me
you
have
don't
a
know,
question. Sir,
yeah,
let me put out some questions, sir. I mean, ask out some questions.
yeah.
So what are all the requirements to become a system engineer as you Cisco, sir? What the
It's
student
not
has to
like
achieve, sir?
you or me, right? That's what I told you. Like,
What are my
whatever you
student has to
study,
achieve?
yeah, whatever you study the concept clearly. That's it. Very simple. If you say, like, for example, they are in second year, right?
Yes, sir.
Okay, maybe they might have studied this data structure, right? Data structures, though they should know what is data structure, where it is applied, right? Everywhere data structures are applied, right? So the basics, be strong in the basics, and just ask the question where it is applied. That's the first thing. See, you are saying in data structure we have binary trees. Okay, where is binary tree applied? search for it. You will come with an answer. Whenever you are able to search for many things on the internet, why don't you spend some time? Applications of data structure, applications of trees, applications of graphs, applications of red black trees, applications of B plus trees, like that. Start doing that. Be strong in the basics. Whenever you study, just put this question: why I am studying this? What's the benefit of studying this? How it is really going to be helpful in my case? See, when you are studying in computer science and engineering, BE, okay, all courses are somehow is going to be helpful in your technical career, right? So it's not just if you study, talking about the front end developers, I mean the full stack developers. Nowadays industry, they want people to be equipped with multiple skill sets, not just an engineering level, right? If you are a front end developer, okay, good. If you know back end databases, okay, good. If you know networking, good, because full stack they are expecting nowadays. So you should know how to design the front end. You should know how to front end designing you can do with Java, Python, or any language, programming language. Then you should know the back end, the databases, MongoDB or whatsoever, okay, or Oracle or anything. Then you should also know how the interrelation, the web server related Apache or Tomcat or whatsoever. Then that's how it should go. Okay, so have a diversified knowledge. Don't be a nerd in only one specific technology. Learn as much as possible. Yeah, Satish said, that's what I'm saying. In computer science, whatever they study, if they study keenly, it will be certainly going to be helpful. But the real challenge will be, what do you study apart from what is taught, right? If they teach what is binary tree, and if you go a level beyond what are the applications of binary tree, even if that is not in your curriculum, that will add value to your profile, right? Yes, sir. Next.
Thank you, sir. Students, any questions, please ask to sir. Anyone? Anyone, you can unmute and then you can ask your questions. If you
Satish
have,
sir is a good guidance, guys. You may take his help because I know him for the past 1 decade, more than 10 years. So he's really a very helpful guy. You may reach out to him for any assistance.
I'm doing it, sir. I'm doing now. Thanks, sir.
Hmm.
Students, any doubts, please ask him because you are in the second year. You have ample amount of time left so that you can get some guidance from sir, and then you can focus on your things on for the next 2 years. So please ask your questions. Anyone? Anyone, please. Okay.
Okay, then. Thank you, guys. Thank you,
There's
sir,
no
for
questions.
this opportunity. Yeah.
Okay. Any questions? No. No, there is
I
no
think
questions from my students, sir.
that's fine. Mm.
Okay, sir. Thank you very much, sir. Again, once again, on behalf of Panimal Engineering College Management Department of Computer Science Engineering, our HOD madam and our coordinators, conveners, I thank everyone to be the part of this 3 days workshop, and also I wanted to extend my heartful thanks to our resource person, Mr.S.PRABHU SUBRAMANIAN, for spending his valuable time on this 3 day session. Apart from his work, he has to work
I
for
did only for
an
you.
entire day.
I did
Yeah,
only for you.
you have to work for the entire day, and then you are sitting here for our students for the next hour also. So thank you, sir. Thank you very much. So
Yeah.
students, I I just wanted to thank all your patience and be in the session, and then I'll be sharing you a feedback link and third day feedback link, and you will be receiving a certificate soon. Thank you very much, sir. Thank you,
Yeah, thank
students.
you so much. All the best, guys. Do well. Keep rocking. Take care. Bye bye.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you. Thank you.
Thank you.